This chapter 2 introduces FX outright forwards, their quotation conventions, and their pricing methodology, familiarizes you with forward points and how to think of them, and analyzes the sensitivities of forward contracts to movements in FX spot and interest rates. A forward FX transaction involves the exchange of currencies at an agreed rate for a value date other than spot. The standard forward periods are known as fixed or straight dates and have the following maturities: 1 month, 2 months, 3 months, 6 months, and 1 year. Any value date that falls between these periods is known as a broken date. The forward value date is calculated from the spot date onwards by sliding the spot date forward by the period in question. Thus, a 1 month forward has a value date 1 month from the spot date. Let's suppose that a euro-dollar deal is transacted on October 14 for 1 month forward. The spot value date of the transaction would be October 16, as we discussed previously. To determine the value date of the forward, we need to slide forward by 1 month exactly from October 16, which brings us to November 16. But since November 16 is a Sunday, then the next business day, November 17, will be our 1 month value date. Some emerging market economies impose foreign exchange controls and do not possess a forward market for non-domestic participants. Since, for some parties, it is therefore not possible to physically transfer the domestic currency at settlement, the non-deliverable forward, or NDF, was created as a way to circumvent this restriction and allow hedgers and speculators to establish a long or short position on the domestic currency. While a regular forward normally involves a physical transfer of currencies between counterparties on the settlement date, the NDFs are settled on a net basis in the single currency for which no transfer restrictions exist. The only transfer that takes place is the net difference in cash flows or settlement amount. The NDF market uses the central bank spot fixing 2 business days prior to the value date of the forward transaction to calculate the net settlement amount. We will illustrate how this works next. Take a speculator who is bullish on the dollar versus the Chinese yuan and uses an NDF to buy $10 million 1 month forward at 6.8625 against the yuan on November 17, 2008 for value date December 19, 2008. If on December 17, 2008, the spot fixing is 6.8675, the bank will deliver on December 19 a net settlement amount of $10 million times 6.8675 minus 686.25 divided by 686.75, which is equal to $7,280.67. Conversely, if on December 17 the spot fixing was 6.8575, the bank would receive from the speculator on December 19 a net settlement amount of $10 million times 686.25 minus the spot fixing of 685.75 divided by this spot fixing, which is equal to $7,291.29. Note, incidentally, the small difference in the two US dollar net settlement amounts, which results directly from the fact that the yuan differential inside the parentheses is equal in both cases, but is being divided by different spot rate for conversion into US dollars. Forward prices are rarely quoted as such in the FX market. Dealers prefer to work with forward points because these often remain quite stable even when the spot rate is experiencing fluctuations. The table in front of you illustrates a typical screen display of spot rates and forward points. Note that in the column for the Canadian dollar and for the Norwegian krona, the forward point quotations are in ascending order. For every maturity from 1 month to 1 year, the bid side of the forward points is smaller than the offer side. In all the other columns, the quotes of the forward points are in descending order, meaning that the bid side of the forward points is greater than the offer side. For example, the quote for the 6-month Canadian dollar forward points is 16.25-16.80, which is in ascending order, while for 1 month euro, the quote for forward points is 26.50-26, which is in descending order. A forward rate is equal to the spot plus the forward points if the quote of the forward points is in ascending order. In this case, the forward rate is said to be at a premium to spot, meaning the forward rate is greater than the spot. Conversely, a forward rate is equal to the spot minus the forward points if the quote of the forward points is in descending order. In this case, the forward value is said to be at a discount to spot, meaning the forward value is smaller than the spot. In our table, the forward prices for Canadian dollar and Norwegian krona are derived by adding the forward points to the respective spot rates, while for all the other currencies, the forward points are subtracted from the respective spot rates. We now calculate the 1 month forward bid rate for euro dollar. Because the 1 month forward point quote of 26.50.26 is in descending order, we must therefore subtract the 1 month forward point bid rate from the spot euro dollar bid rate. It is necessary when doing so to align the digit to the left of the decimal of the forward points quote directly underneath the last digit of the spot quote. In this case, the 6 from the 2650 has been aligned directly underneath the 8, the last digit of the 1.5628 spot quote. In other words, because euro-dollar spot is quoted to 4 decimals, the forward points are in effect being divided by 10,000 before the subtraction is executed. In a similar vein, when calculating the 2-month forward offer rate for dollar-yen, the 2-month forward points offer rate must be divided by 100 because dollar-yen is quoted to 2 decimals only before subtracting them from the spot offer rate. Of course, we subtract the points in this case because the forward points are quoted in descending order. Finally, if we are calculating the 6-month forward offer rate for US dollar versus Canadian dollar, we need to add to the spot offer rate of 1.0779 the 6-month forward offer points of 16.8 divided by 10,000 because the spot is quoted to 4 decimal points. In this case again, we add the points because the forward points are quoted in ascending order. The exact formula for pricing in FX forward, which takes into account each currency's day count convention, appears in this rectangle here. If either currency is quoted on a 365-day basis, such as the British pound, replace the 360 with 365. Let us price using this equation the 6-month euro-dollar forward when spot is 144, the 6-month dollar interest rate is 2%, and the 6-month euro interest rate is 4%. We also assume that the exact day count for the 6-month period is 181 days. For now, we ignore bid offer. We remind you that in the euro-dollar quote convention, the base currency is the euro, while the term currency is the US dollar. This yields a euro-dollar 6-month forward rate of 1.4258 in cell D15. This, of course, also enables us to derive the 6-month forward points simply by subtracting the spot rate from the forward rate to obtain 142 points. Please note that the forward is trading at a discount to the spot here because the euro interest rate, which is the base currency interest rate, is greater than the dollar interest rate, which is the term currency interest rate. In this situation, a dealer who establishes a long euro 6-month forward position against the dollar could now borrow euros for 6 months at a 4% rate while lending dollars for 6 months at 2%. This borrow and lend position would be fully hedged by the forward he has entered into, with the cash flows from the forward being offset perfectly by the cash flows at maturity from the repayment of the loan he has made and the maturing of the borrowing he has undertaken. It is, of course, necessary to ensure that the amounts of the investment and the loan are set to be exactly those amounts that would perfectly offset the cash flows on the right. The specific amounts in each currency that he would borrow and invest have just appeared. The euro loan would have a principal of just over 9.8 million and would incur interest over the 6-month time period, applying the 4% interest of just under 200,000 euros. The US dollar investment he has made would have a principal of just over 14 million and would earn interest of just under 142,000, representing the 2% dollar rate applicable over 6 months. Since the dealer is borrowing at the higher rate of 4% and lending at the lower rate of 2%, he would be paying a differential known as the negative carry of 2% on the notionals. This is reflected in the previous worksheet by the fact that the 6-month forward rate on the euro dollar is quoted at a discount to spot. By the same token, a dealer who establishes a short euro 6-month forward position against the dollar could now lend euros for 6 months at 4% while borrowing dollars for 6 months at 2%. This borrow and lend position again would be fully hedged by the forward he has entered into, with the cash flows from the forward being offset perfectly by the cash flows at maturity from the repayment of the loan he has made and the maturing of the borrowing he has undertaken. The dealer is therefore earning the differential, or the positive carry this time, of 2%. This is reflected by a short sale of the euro-dollar forward at a discount to spot. Let us price, using our equation, the 6-month dollar Norwegian kroner forward when spot is quoted at 5.0250. The US dollar 6-month interest rate is 2%, being the base currency interest rate, and the kroner 6-month interest rate being 5%, the term currency interest rate. We assume again the exact day count for the 6-month period is 181 days. The calculation yields a dollar kroner 6-month forward rate of 5.1000. Therefore, the corresponding 6-month forward points, derived by subtracting the spot from the forward, amount to 750. Please note that in this situation the forward is trading at a premium to spot because the kroner interest rate, which is the term currency interest rate, is greater than the dollar interest rate, which is the base currency interest rate. In this situation, a dealer who establishes a long US dollar 6-month forward position against the kroner could now lend kroner at a 5% kroner rate while borrowing dollars at 2%, thereby matching his forward position just as before. This borrow and lend position, as before, would be fully hedged by the forward he has entered into, with cash flows from the forward offsetting perfectly the cash flows at maturity on the left-hand side. Since the dealer is lending at the higher rate and borrowing at the lower rate, he would be earning the differential or positive carry of 3%. This is reflected by a 6-month forward rate on the dollar kroner trading at a premium to spot. Using our previous euro-dollar example, with spot euro-dollar at 144 and US and euro 6-month interest rates at 2% and 4% respectively, we now consider the situation where a dealer goes long 6-month forward euro dollars at 1.4258 on a notional of 10 million euros. In this worksheet, cells D10 to D20 show us varying the spot by increments of 1 American cent per euro. Column E calculates the corresponding forwards using the outright forward formula we have worked with previously. Column F shows for each forward level the gains or losses expressed in US dollars that the dealer would achieve on the settlement date if he were to enter immediately into an offsetting forward at the rate indicated in column E. And column G shows the present values, also expressed in US dollars, of these future gains and losses using the 6-month US dollar interest rate of 2% as the appropriate discounting factor. An investor holding a long euro-dollar forward position would therefore gain from a move up in spot and would lose from a move down in spot, while an investor who is short euro-dollar forward would have the opposite result, i.e. a gain from a move down in spot and a loss from a move up in spot. We wish to emphasize one very important point. Present valuing the gains and losses at settlement, as we have done in this column G, is the accurate reporting and accounting method. However, the common practice in some trading rooms and brokerage reports is to report the gains and losses from a forward contract that would accrue at settlement, i.e. their future value at settlement, as appears in this column F. The reason for that is that the differential between the PV and FV, future value, of these amounts is negligible in the context of a short time horizon and moderate interest rates. For longer tenor forward transactions, however, or in very high interest rate environments, it would become very crucial to present value the future gains and losses, since the discrepancy between PV and FV would become more significant. Let us now look into how the forward rate is impacted by movements in the interest rates for the base and term currencies. Using the outright forward formula again, we can derive the formula for the forward points from the definition of the forward points as the difference between the forward and the spot. Here is the formula in the rectangle on which we have just clicked. Let us assume now that the spot remains constant and that it is the interest rates that can fluctuate. Movements in the base currency interest rate would, it is true, have some impact on the denominator of the formula, but this impact will be small in comparison to the impact on the numerator, which will be discussed shortly. For the sake of simplicity, we therefore assume that the term in the denominator remains constant and can be ignored as the base currency interest rate changes. This leads us to the conclusion that the forward points are principally affected by movements in the differential between the base and term currency interest rates. Let us use the same example as before, with spot euro-dollar at 1.44, the 6-month US dollar interest rate at 2%, and the 6-month euro interest rate at 4%. The initial interest rate differential, shown in this cell D15, is therefore minus 2%. We now vary this differential by increments of 0.5% by keeping the base interest rate constant at 4% while allowing the term currency interest rate to fluctuate, as you can see in this column E. We also hold the spot constant, as we said, at 1.44. You will readily observe that as the differential becomes less negative, reflecting a tightening in the interest rate spread, the forward value increases. Conversely, when the differential becomes more negative, reflecting a widening in the interest rate spread, the forward value declines. We could alternatively have held the term currency interest rate constant while allowing the base currency interest rate to fluctuate, or even allowed both interest rates to fluctuate, and would have found the same results. You should click the pause button and confirm to your satisfaction that these statements are true. In columns G and H, we show the future and present values of the gain and loss for a dealer with a long euro forward position established originally at 1.4258. Therefore, the dealer holding the long euro-dollar forward position would, in our example, have a gain from a tightening of interest rate differentials and would have a loss from a widening of those differentials. An investor holding a short euro-dollar forward position would, in our example, have the opposite result, i.e. a gain from a widening of interest rate differentials and a loss from a tightening of those differentials. This completes this chapter 2 and part 1 of this module, Introduction to Foreign Exchange.